مساء الخير اخوان. مرحبا بكم باللقاء الاسبوعي بمنتدى الثلاثاء الثقافي. محاضرنا اليوم اخونا الدكتور رشيد. عنوان المحاضرة تحليل 5 كوارث من صنع الانسان واثارها، التكملة اللي خلاص على الديزاين. فنبدأ بس مختصرة عن رشيد الصفار. رشيد من مواليد بغداد سنة 62. تخرج من جامعة بغداد، جامعة العلوم بالفيزياء سنة 85. حصل على الماجستير من جامعة مانشستر عام 88 من الماتيريال ساينس، كمل البي اتش دي ايضا في جامعة مانشستر سنة 92 بنفس الموضوع اللي هو الماتيريال ساينس. قدم 12 أطروحة scientific papers، ما أعرف شو ترجمتها بالعربي، العفو ثواني. عنده research، هو research fellow at the University of Manchester between 1991 and 1993. عمل في ماليزيا في ماليزيا Research Institute من 1993 to 1995، وكذلك كان research fellow في جامعة تورونتو سنة 1996. 1997 حول اختصاصه إلى الانفورميشن تكنولوجي، ومن 1997 ولحد الآن يشتغل مع IBM كسينيور شيف تكنولوجي اركيتكت، working in different disciplines and departments. حصل على الماستر certificate in architect by Open Group، و he published 10 internal papers and essays. وكذلك هو من نجاحاته هو في إنشاء هذا المنتدى الثقافي، واحد من المؤسسين في عام 2020. اتفضل أخ رشيد وتقدر تبلش الشير.
شكرا جزيلا أخ صالح. Let me hopefully you see the presentation.
And we see your
just desktop, yeah.
Yeah, the desktop.
Just one second. Okay, we'll start. مساء الخير اخواني الاعزاء، حضرة الاساتذه القديرين. اليوم محاضرتنا about 5 man-made disaster والimpact on the design and how we learn from it. السبب الرئيسي بهاي المحاضرة انه من University of Manchester I worked in the field of failure analysis. الطروحات مالتي اثنيناتها basically was physical and mechanical properties of ceramic material. Main job was mainly looking at failure analysis of different material at different temperature, different pressure, and we photograph all of that. So basically I learned a lot from photography by trying to follow the trail, more or less like a forensic science. سبب المحاضرة هي لطيفة، خفيفة. أعتقد كل اختصاصاتكم بالهندسة، بالإنجينيرينج، بالماتيريال، بالكيمستري will contribute to it. بس the reason I wrote this المحاضرة إنه كانت خلال تريب مالتي إلى فورت إيري. فورت إيري صار على نياجرا ريفر which is على بالضبط على ليك إيري. بالزيارة هناك كان اكو الفورت which is بنوها الانجليز اللي كانت احدى الحاميات هناك. When the British came and they set their first camp, because we went for a tour and the guide told us when the British came first, in the 1700s, they built their camp exactly by the river, sitting there, and they noticed that the Aboriginal people or the native people, they basically built their houses, far, far away on the top of the hill. So traditionally, by the river, you can fish, you can swim, you can get water. You just you're 1 feet away. So when the first spring came out after the winter, of course, the lake is flooded and the river flooded, and basically the whole camp is gone. So basically, this is the whole idea about learning from the native or the original people about. So this is here is Fort Erie. I hope you see that. And then if you follow they
Can
call
you
it
share your screen, please?
There's no sharing?
No.
Oh, okay. Yes. Just once, what's happening? Okay. What is the Zoom? Oh, sorry. Sharing the screen. Okay, and I will put it in.
Okay. Just here.
Now,
Okay.
now it's better. Okay. Sorry for that.
Okay.
So we'll go back. So really, Fort Erie, if you see it here, and the river is just at the end here, is sitting here, and this is really the whole area they left it there. So if you have a trip one day, you can follow the Parkway River, and there are 3 forts actually, Fort Erie and Fort Niagara. And if you cross the river to the U.S. side, you'll see the U.S. fort, which is built by the Army. So that's the reason, basically, I said, let's write a presentation about, the man-made disaster and its impact. This is just the introduction, basically. The first one we talked about, the Derna Dam, just happened in September last year. What is interesting, but of course, I'm not in geography and everything, but from all the science and learning and knowledge. So basically, if you look to the Derna, which is about 20,000 people died, you see this is the gorge. This is one of the gorge, which is basically has all, when they have the storm and everything, collecting all the water type of thing. So the dam they build is not really a proper dam. It's basically just to control the flood, and mainly just build from clay and rock and everything, and just they make it so big to that. In Derna case, they build 2 dams: the primary dam, which is basically they call it Derna Dam, and the secondary dam they call it the Mansour Dam, which is basically close to the town itself. This dam basically it can hold 30 million cubic meter of water. Just imagine with how much water it can hold. Does not hold it in a specific reservoir. It's actually just hold it in the valleys and the tributaries of the river itself. So they didn't expect that the dam is going to fail. But if we look at the construction of the dam, if you look here, so this is the first dam here, and they have the valley, and you have the second dam, which is here. But if you look from the photography picture from high, similar to the delta, the Nile Delta, or the delta in the south of Iraq, when you see the river over many, many years, they have a flood zone and a flood line. If you see the area when you showed in the second picture, you see it's covered like one time of a flood. Usually the whole area get covered. But one of the design mistake they did, they built all the city around it, where is actually the flood line, all the flood zone. They didn't take into consideration that if you have this area which is getting flooded maybe every 100 years, maybe every 200 years, the city should not build here. The other mistake they did is that this is a big dam, and this is the smaller dam in terms of the size, the construction. But the biggest mistake usually in the design is that when this dam fails, there is a surge, a huge amount surge of water. We talk about 30 million cubic meter of water will come down, and this is a smaller river, of course, will not take the impact itself. The other things in the design, the mistake they did, is that if this is basically an aerial photography, the dam is here. I hope you see my mouse where here is really at the end of at the bottom at the bottom and left corner of the pictures. But you see there are two valleys, two huge valleys, and these valleys can collect water for a long, for amount of time here. So you have two gorge protecting by a clay dam here. So they should take into consideration in the design is that technically they should build a proper dam here, another dam. So there is a difference in the dam design. Like if the dam is just to hold the water, like, you can do it yourself, just, from a clay and rock. But the dam, usually it had to have a gate, it had to have a escape route, it had to be built from concrete, and we'll see it in the second picture here. If you see the picture here, it's just a dam made from a clay and rock, and just there's a road on the top of that. And you can see the other picture I showed to you. You see the two gorge here? The two gorge, they come here, and that basically build a lot of pressure on the clay dam itself. The another design mistake, if you look to the escape, they call it the escape funnel. Usually this funnel, if you see it here, is really at the top, nearly on the top of the dam itself. Technically, is that this escape should be much lower, so the water can funnel, basically excess water can go here. But there's another design mistake. They have only one funnel, because this dam, if you look at this side here, and you look at this side, there is no gate. Usually in the dam in Iraq or any other area, or Hoover Dam, you have a gate, which is basically you open it and let the water come underneath the dam. The other mistake they did is that they really underestimated the power of water. Water is basically, when they come in a masses, is become continuous medium. The water, one of the property of the water, basically because of the bonding between the hydrogen and the oxygen, become like one sheet of things, not like a broken in pieces like an ice. You have isolated piece. So the power of the water as they move, the power of the fluid basically will hit the dam. So the day before the dam, I saw a video. There is an engineering guys who are sitting here, and the water is up to here where you see my mouse here. And where they are standing, you can find this video on the YouTube, where they are standing here, one of the guys, the engineer, asked him, say, we feel that the dam is moving. So really what the water, because the water is basically, it go like, in a wave. So there is wave coming in and hit, coming wave and hit on all of that. And basically just the water will find the way and break it up. So the whole design structure and the way they did it and left it for many years without maintenance, without a proper type of thing, is basically led to the disaster itself. So if you look to the picture of the city, so if you notice in the city design, you see the city, the population is by the river, and traditionally human being, and they like to stay by the river, for boating and everything. If you look very closely to this picture on the left, you see that the river bed is dry. There is no water in it. As long as the last 100 years or before, or 50 years, really there's no much water, just trickling along. It's not like a live river where the water is spinning all the time. And they build it, people, they took it as a granted, what is the odd will have a flood to there. So even the city design was a huge mistake to here, because they basically, if you look to this picture on the bottom left, see the smaller dam sitting here. And if you compare the size of the dam to the gorge itself, there's a huge amount of, basically this dam will go on the second. So what caused the disaster? You have the first dam fail. You have 13 million cubic of water. The water come rushing, and it from the acceleration force. As the water come down, gushing about 10 kilometers in a valley in very channel, is basically the force will be humongous. So this dam is actually, when it exploded, the people said in the videos, exploded like a bomb. Like it's basically it just shut to that. So if we go to a little bit from the analysis, if you look at this picture, which is basically by European Union, you see the flood zone. the flood zone, you know how big it is, basically pretty much cover the whole city. Like in city design and everything, you should not, basically this is will be considered the forbidden zone to build any housing or anything. Here they call it the flood mark. Usually the flood mark is very important to say, okay, we know about over the many years that the flood reached this point, so basically you should not build anything on that. Here in Ontario, basically, like if you work in the cottage country and that area, all the time, especially if you by river or lake and you want to build a cottage, they will tell you this is the flood zone, which basically you cannot build anything on that flood zone beyond that flood zone itself. It's a very interesting picture I saw in South Asia is that, you know, if you see all the houses in South Asia, in Vietnam, Cambodia, usually they build them on a pillar and the house is on the top. And usually they write down on the pillar with a marker, you know, year 1950, the water got here, 1955, the water got here. Basically, this is what we call the knowledge of the indigenous people or the native itself. But here is basically one of the disasters they have is basically they took it for granted. And, you know, we'll talk about what the thing is caused the problem itself. So the warning and aftermath, built in 1973, just give you some statistics. Early sign of a crack in 1988. So basically pretty much for 20 odd years, they did not do anything. Of course, as usually in that region of the world, no maintenance, no inspection, you know, and they contracted a Turkish company basically to inspect the dam, fortify it and all of that. But actually was a problem with the contract and the wording. And basically the British company say, well, here we are here just only to maintain it, not actually basically to fortify it or build it and all of that. And of course, planning and politics and the war is supposed to have a proper dam itself. So really, this is now you won't consider the dam. People work in civil engineering and dam construction. They know that really this is not a dam, pretty much just a rock and sand built to the. What is interesting things is that, you know, there are smart people. In 1922, Umar al-Mukhtar University, there was a thesis or a paper is being published by an engineer there, and it basically telling them that the dam is now safe and the risk is unmanageable with the high level of water. If you put all these together, is that, you know, they ignore the warning, they warn on the sign, you know, leave it without that basically, and just take it for granted. So this is the first one. I hope I didn't go fast, but I just need to be considerate of the time itself here. So the 3 Mile Island accident, all of you know about it. Is basically the nuclear power station is basically just, you know, it was a disaster. It's just basically the core of the nuclear reactor is just melted. So what will start a little bit slowly here, little bit basically is that was the accident, partial core of the nuclear meltdown. They classify as accident with wider consequences because they have different level of on the scale. They have it from 1 to 7, and this one was on level 5. It happened in Pennsylvania, in Londonderry Township. And basically it marked level 5 out of 7. So really is a major impact. They had to evacuate 140,000 people. And the radius of the radiation was between 5 to 20 miles. The TMI, which is a stand for the 3 Mile Island Reactor 2, the cleanup took up until 1979, from 1979 until 1993. So it took us a long time to clean it up, similar to the Fukushima plant, which is basically happened because of the tsunami, which is going to take very long time to clean it up. And the cost is about $2 billion just to clean it up, not talking about all the radiation and the impact on the pit. So that's a summary. So really here, just give you one-on-one. I'm not a nuclear engineer by design, so just to be clear here. But let's give you the basic component. You have the cooling tower. When you have heat, basically this tower is just job to cool anything. The building here, they called it non-radiation building, which is you have the turbine, the generator, the transformer, and the pumps and everything. And this is basically where you see it under the dome is basically the heart of the nuclear plant. There are a couple of things you need to notice that. This is the core, which is hold all the nuclear fuel. On the top is the control rod, which is basically, they call them the moderator. Their job, if things go out of control, these drop. Similar to what you have, a water bucket on the top of, and you throw it on the fire type things. This is really the pressurized vessels where all the things happen here. And you basically here where is the heat exchanger between the coal and the hot, and basically generate the steam here. There is a bunch of valve and safety and all of that we'll talk. So this is really the primary building, and this is, they call the secondary. This is very high level. You can find all this information on public. There's nothing special about it. So really you have an idea, the turbine, the cooling tower, and the core. That's basically three things you need to know about. So what caused the primary disaster? Very simple thing is a human error. So basically what happened is that if we go back to, we go to the picture here, like these pumps, basically there is a filter. In the filter, basically, they have, because the water come from here, it has contaminated and some resin, they have to take the filter out. And basically they have to use compress air and clean it out, you clean all the residue and everything and this polymer particle there. So basically, like similar way you clean your filter in the furnace or you place it. But what happened is that one of the operating guy, they have a problem to clean up the filter. So it's decided in his wisdom that, you leave the filter in the water and basically, blast it with the air compressor. Okay. So he didn't realize is that basically when he did that, some of the blockage, the resin filter that we talked about, let me just read it. Basically, some of the water of the air get into the compressor, whereas basically you have it like if you're using the brake, and basically you have some air in whereas the brake fluid get in, the compression is going to be very hard basically to press the brake itself. What is interesting is happening is 11 hours before the actual incident itself. So really just a human error, done very quickly without basically any consultation, and there was one small error. Basically, small amount of water forced its way to the stack up open valve, basically, and found its way to an instrument airline. That's basically what happened. Basically, water got in the instrument airline, and that basically you're going to see in the next chart. A major sequence of event. What happened. So it's very interesting. It's happened 11 hours before. So I have a chart for you here. So basically, I did break it up in a small chunk of pieces here. So the cleanup at 5 p.m. on the 27th, basically some of the water get to the air instrument. Basically, the feed water pump condenser find its way. It basically didn't work. In this case, it took about a few seconds. The turbine shut down because he's not getting the water he needed from the condenser. So automatically they have safety tripped here. This one led to increase the pressure inside the vessels, the core vessels is basically to 2,355 pounds per square inch. Yeah, if you do the math, yeah, you're talking about, I don't know, about 2 tons or more than 2 tons per square inch. You see the difference when the turbine trip is only took 8 seconds for the reactor to trip, okay? Basically, here, as I talked to you about the cooling rod, the top rod, the moderator, they drop, basically, more or less to stop the chain reaction here. Even the rod drop is still, you have a decay heat. It's still like you cannot basically, it's not like, we switch on and switch off itself. And this one, that the short story here, led basically to partial meltdown on the core by 4 4 p.m. So you start at 5 p.m., but you see the sequence of the event, how it happened here. But at the bottom of the chart, we go in more details how to the things will happen. So when the reactor is shut down, or basically the story did not finish here. You should, everything should be fine. But actually, if we follow the timeline, is that about 7 minutes later is basically you have a coolant to start to leak. The coolant is basically is not like your regular coolant. It's basically that what it go inside the reactor and basically take all the excess heat and basically pass it to the heat exchange chamber, and that when there is the cold water meet the coolant pipe, and basically that way you generate the steam. But what they found out is that 120,000 liter of coolant, and basically this is the radioactive things stuff, is got leaked to the reactor basement. What happened here is that the relief diaphragm over the pressurized tank is basically got ruptured just about 4 minutes later, correct? And then by an hour later, the primary loop, which is the 4-reactor coolant pump, is basically get cavitated. What is cavitation is in the engineering is that when you have basically, you have air and water get mixed up, and basically they produce a huge amount of force, is basically can shatter a material. Similar when you have in the blade for the motors, when you have an air gap form around the rotors and the water, and basically that will cause the rotor to be shattered. By 6:05, basically you have the melting fuel rod and the cladding, which is basically the container which is keep the thing is got melted down. And that basically when the top core reactor, boom, got exposed. At 6:45, this is very interesting thing. You see between this disaster here and 4 p.m. and they did not basically declare any emergency and everything until 6:45, which is that's against all the rules and regulation. When you have a disaster shutdown here, basically you have to declare a disaster itself. And then by the time where they know they have 120 liter basically seeping on the floor, they could declare a site emergency. And finally they declare, the highest emergency, what they call a general emergency, by that time. So if we go to the sequence of the event, so basically in the analysis is that you have no feeding water coming to the reactor. Of course, you don't have a steam. The heat transfer basically will be reduced in the reactant coolant system. The temperature go up, the coolant expand. You have surge into the pressurized vessel, the one we talked about. You have compressed steam bubble at the top, which is the most dangerous things. The pressure pushed to 2000 psi, and the pilot operating recovery valve open, the relieving steam through the emergency tank, but the pressure continue rising to the trip point, where is basically, the trip point, you have a setup of emergency to that. And basically the rod drop, but basically the process of the shutdown is just happen after that. So without give you a headache too much about it, let's talk about contributing factor. So there is another problem after the investigation, what they found out. One of the things is all about operation. It's all about a human error. So sometimes automation is useful, but you still need to have the human being itself. The operator did not notice that the block valve was closed in the 2 out of 3 emergency feed line. He did not notice because the emergency valve supposed to be open, and then basically that where is the water, so it can go to the reactor in case of emergency. Okay. The other interesting findings, one of the valve was covered, with a yellow bag, because was done, because they are doing some emergency the day before, and the guy forgot to remove the bag, so the light of on the valve can be seen. It is open, is it closed type things, type thing. The other things that they found out, the operator is is not trained properly to understand the ambiguous nature about how these valves they work and what does the light indicator mean, if it is red, if it's yellow, if it is green type thing. And the biggest problem is that they could not, because when you have a problem with disaster, you have to diagnose what is the problem itself to find a solution. In this case, they did not have a clue for many hours to say, okay, where is actually is the problem itself, correct? And then, of course, the training and all of that on the top of that. But what is interesting they're finding is that it took the operator, which is the owner, between 2 hours and 35 minutes, basically to raise the alarm to say we have a problem, and especially in this type of environment. And took 3 hours and 26 minutes basically to declare general emergency. So basically these are contributing, basically human error, training, not seeing understanding how things work, and basically taking too long basically to call the URA team to fix the problem itself. So now we go, I hope I'm good with time. I don't know what's the time now, but anyway, I have 8 minutes, but I'll ask for
8 minutes left.
Yeah, can I ask for just a little bit of extension? I'll move very. Halifax Harbor fire. This is very interesting one happening during the World War I. If you go to Halifax, which is the East Coast, basically they have a nice harbor there. That's in the Halifax air map. And basically the harbor, which is being due to the Atlantic, and you can see the area is very narrow between the Dartmouth and Halifax. Used to be this is the harbor pictorial picture from. So basically, if what happened is that if you really what happened is the disaster happened in this very narrow, and that basically one of the factors is good when you have an explosion and you have very defined area. Basically, the way the sound wave is travel and the impact have a major things here. Just to show you number 7, when the explosion is happened between two ships, you see number 7 here? This is where they found the anchor of one of the ships. You see how far from the force of the explosion, just to give you an imagination how big. It's considered one of the biggest explosion in history. There's about 3,000 tons of explosive material type thing. So it's happened in December 6th. Was a foggy day, of course, in the winter in that area of the world. Basically, was very simple. Two ships collided to each other at 8:45 a.m. Basically, the smaller ship tried to avoid a boat there, basically, and just went directly to the other ship. 3,000 tons of explosive when the Mount Blanc ship was carrying. The root cause is colliding, of course, the two ship because of changing of course, not following the rules and the direction of the maritime. And then the bad weather and high fog basically contribute to the disaster itself. So just to give you an idea, the force of explosion is that six square kilometer of Halifax was wiped out. What I mean by that wiped out is totally destroyed, bare bone to the ground. The shock wave fell to 300 kilometers away, and the explosion killed 2,000 people. Remember, this is in the harbor on the side, and wounded 9,000, and basically windows broken 75 kilometers away. Okay, so this is give you a picture of the size of the disaster you have. This is the harbor, and you can see everything flattened, the building itself. And this is considered one of the biggest explosions in the world. This is very quickly, we go to it type thing. Really what here, that route is happening is that there is something came out of this disaster. First of all is that they changed the maritime rule, how the ship interact with each other in the harbor. They have to declare the goods on each ship because nobody know that this ship is carrying 3,000 tons of explosive. Basic, and also they have to push the residential area away from the shore itself. They did not have the material or the hospital or the emergency to deal with these 2,000 people killed instantly. Most of you, the last one is about the Exxon Valdez oil split. I think most of you know about it. What is interesting, this one has some relation to Iraq, and I'll explain to you in a second. It's happened in the Alaska, and it's exactly in this point where you see the marker here. You see it's such a beautiful area and channel, and basically you have here the Pacific Channel, and you see all these small island and reef. So navigation for the seawater is very important to know the area itself. And again, was a mistake by a human error. So that we go back to it. So the Exxon Valdez is considered the second largest oil spill after the Deepwater Horizon, which happened in the Gulf of Texas a couple of years ago. Located in Prince William Sound, Alaska, happened on the morning of March 24th. And then basically the oil super tanker, single hull, please pay attention to the word single hull, ship is basically hit a reef, which is 6 miles away from where is the port she traveled from. The spill is about 10 million US gallon of crude oil, and then affected an area about 2,000 kilometers from a shoreline, and basically habitat for salmon and otter and all of that. People following the environment has this impact. But the problem was very simple mistake has been done. So before we go here, I want to give you a lesson about 101 of boating if you don't have a boat license. So just remember these things. Sorry. You have the bow, which is the front. They call it the bow. And I'm sure some of you know. And the stern is the back. They don't call it right and left because it's getting confusing depending on your direction, how you are facing the ship. They call it the port, which is basically all the time on the port. You basically that's where the ship park. So basically the left for them is considered the port, and the starboard is the right. So this is 101 boating. So how it's happened, I spent time to make it, in a sequence of event investigation. So really on the night of the 22nd, the Exxon Valdez docked on the port. It get loaded with oil crude. A ship left the next day at 12 p.m. Correct? At 29:25, 3 minutes later, the captain, he told them, sorry, I'm tired. I'm going to go to my cabin, whatever. This has been a long day for him. So any ship leave a harbor, a terminal, that had to be combined by what they call the harbor pilot, which is a person basically knowledgeable about the harbor, the island, the reef. And basically, if you see all the ship when they leave a harbor, there is a tugboat in the front. And basically, the harbor pilot is very important in the people from Basra, they know that. Basically, the pilot is the important guy to guide you until get you to the open water. So that's his job. So by that time, basically at 11:24 p.m., the captain called to the bridge, because what happened, you have only the third officer was on the bridge. So you have the pilot harbor and the third officer driving the ship on the top, which is against rule and regulation, because at least you have to have 2 or 3 people on the bridge. And then basically, because the pilot need to leave, so they call the captain to come to the bridge. The third officer helped the harbor pilot to disembark, because basically he took him out of the dangerous channel. And basically he left at 11:25, correct? The captain left immediately after that. What happened? The third officer advised the traffic controller and decided what happened. They saw some sort of an iceberg. So the third officer, he was the only person on the bridge. So he saw some sort of an iceberg because, in that time of the year, usually an iceberg would be floating by. So what basically he determined in his wisdom to basically divert the ship, correct? So at 11:47, the ship left the traffic eastern boundary, which is fine. What happened here? You have a people where they call them in the lookout, which is on the top of the sari or the pole. Is basically these people, they are looking and they found out that it is funny thing. We go back to this page. They supposed to see they're supposed to see because you have a reef here, they're supposed to see the lighthouse on the right side of the starboard. But actually what they found out that the people on the top of the lookout, they find it is on the left of the port. That means basically the ship is entering the reef area. And that basically at the 12 a.m., basically the ship, by the time he's calling the captain to come to the bridge, the ship basically run to the ground. What is interesting about this fact is that if you see the ship, only 2 hours and 48 minutes its journey, not that long journey, between the port of Valdez and basically to the open water and basically run to the ground. And there is some interesting fact about it. Mainly telling most of the accident, the car accident, happen is that actually more likely closer to your home than somewhere area else, because you'll be in hurry, you want to beat the traffic and all of that. So this is and of course one person be on the bridge itself. So I did some picture for you here. So this is the Valdez port terminal. So the guy, the harbor port and the third officer, they guided the ship is to here. So basically, instead of following this line and go to the open water, basically try to avoid an iceberg, basically he went to the big island reef and basically ran to the ground. So very quickly, a contributing factor, and I do apologize, took a little bit longer. You have one person on a bridge, which is a guest company policy and accounts maritime. Basically, the exhausting fatigue, long shift for the worker because the third officer was supposed to change the shift with the other one, and the other one did not wake up. So the guy, he decided to do the work himself, which is, fatigue is very important. The other contributing factor, because it happened in very remote area, and the ship never equipped with the equipment to deal with 10 million gallon of water. So basically become a hindrance to the recovery process, and basically preparedness, like you don't have the equipment, you don't have the emergency type thing, all run to that. But the main factor is really one person should not be on the bridge. He took a decision without telling the captain about it. And basically that's what the contributing factor of the disaster. So basically a summary for everything: a hallmark of a disaster, usually human error and negligence, inadequate design, poor maintenance, understanding the lifespan of infrastructure. Nothing lasts forever, even a human being, they will go one day. Environment consideration, changes in the land and the level of seawater and all of that, the hurricane and all of that. Ignoring no local knowledge about that. The human greed and politics. And in case of the Derna Dam disaster, it took them 20 years to decide to build a new dam, and they never built it. They ignoring all the report. Using unsuitable material in the construction, that is very famous one. Poor planning, and basically ignoring early sign of warning, disaster, material deterioration. Usually junior staff, which is basically the transparency. They say junior staff reporting a problem, and you brush them out. This is not good. Only you go, because we're not listening, we're not taking advice from a guy, and basically take too long to fix a problem, and basically the problem build out. Sorry, I was very quickly. Thank you very much, and the time is for your question time.